Hi students, how are you? I hope that you are doing fine. Yeah, today we are going to study one new thing, that is the fundamental theorem of arithmetic. You must have heard about this fundamental thing. What is a fundamental? We have fundamental rights, isn't it? That means we have something which is allowed by the government, that is fundamental rights. There are 6 of them are there. That is fundamental right to freedom. That is one of the rights. Similarly, we have a fundamental thing, basic thing in the arithmetic. So that is known as the fundamental theorem of arithmetic. Now let us see what is this fundamental theorem of arithmetic. Every composite number can be expressed or factorized as a product of primes. And this factorization is unique apart from the order in which the prime factors occur. Now let us see the first part of this theorem, that is every composite number can be expressed or factorized as a product of prime. You know that the prime numbers, we have already studied the prime numbers, that is 2, 3, 5, 7, 11, 13, etc. Now, what are the composite numbers? The composite numbers are 4, 6, 8, 9, 10, 12, etc. So, this theorem says that all these composite numbers, these can be expressed as a product of prime numbers. That means we can express 4 as 2 into 2 and 6 as 2 into 3. Both are prime because 2 is a prime number, 3 is also a prime number. So we can express 6 is equal to 2 into 3. What about 8? 2 into 2. What about 9? 9 can be written as 3 into 3. What about 10? 2 into 5. What about 12? 2 into 3. That means we can express all composite numbers in terms of prime numbers as a product of prime numbers. Now let us see the second part of the theorem, that is this factorization is unique. Why this factorization is unique? Let us take the example of 12. We have written 12 as 2 into 3. All 3 are prime numbers. Now, when we factorize, when we express 12 in terms of prime number, we will only get 2 times of 2 and 1 3. We will not get 3 times of 2. We will not get 3 2 times. We will get only 1 times. Now they are saying that this factorization is unique apart from the order. So we can write that this can also be written as 3 into 2 into 2. Again we can write 2 into 3 into 2. 12 can be written in 3 forms. Now irrespective of the order, we will get 12 only. That is why the second part says this factorization is unique apart from the order in which the prime factors occur. Now clear? So all numbers, all composite number, you take 1,20,380, you take all composite numbers, any composite number you can express in terms of prime numbers. Now let us see which all are the prime numbers between 1 and 100. You should be knowing at least the prime numbers between 1 and 100. Now you may have a doubt whether 1 is a prime number or a composite number. 1 is neither a prime number nor a composite number. Which is the smallest composite number? Smallest composite number is 4. Now you can see all those numbers which are highlighted in yellow color, they are the prime numbers. There are 25 prime numbers between 1 and 100. You can see the composite numbers which are factorized in terms of prime numbers. Now, you can, let us take a bigger number 32760. 32760. We can, let us take which all are the prime numbers, 2, 3, 5, 7, etc. Now, we will start with the smallest prime number. The smallest prime number is 2. So, let us divide 32760 by 2. So, we will get 1, 6, 3, 8, 0. We can again, this is again a even number, we can divide it by 2. So, when we divide it by 2, we will get 8, 1, 9, 0. We can again divide it by 2, it is again an even number. So, see, 4095 is divisible by 3 because when we add these numbers, that is 4 plus 0 plus 9 plus 5, that is how much? 18. The 18 is divisible by 3. So, 4095 is divisible by 3. So, that is when we divide 4095, when we divide it, we get 1365. Now, let us see whether this is divisible by 3 or not. You again check it. 3, 1 plus 3 plus 6 plus 5 is how much? 15. 15 is divisible by 3. So, this is again divisible by 3. So, let us divide it by 3. So, now is it divisible by 3? Let us check it. 14. 14 is not divisible by 3. So, we will take the next prime number. Which is the next prime number? That is 5. So, let us divide it by 5. So, it is 9 and 1. 91. Now, 91 is divisible by 5? No. Now, let us take which is the next prime number? We will take 7. We will take 7. 7, how many times? 13 times. 13 sevens are 91. So, we will take it again 13 and 1. So, 32760 can be written as 2 into 2 into 2, 3 into 3 into 5 into 7 into 13. Whenever we write this prime factorization, always remember that we should write in the ascending order. That will be better because when we write in the ascending order, we can easily segregate. Now, how many times 3 are there? There are 3 2's. So, 2 to the power 3. How many 3's are there? There are only 2. So, 3 to the power 2, 5 into 7 into 13. So, if they ask you, if an examiner asks you to factorize a composite number in terms of prime, we can say 2 to the power 3 into 3 to the power 2 into 5 into 7 into 10 into 7 into 13. So, let us go back to the same theorem. The same theorem it says all composite numbers can be expressed in terms of prime number. Now, the order, it is unique because whenever we factorize this number, we will only get these prime numbers. We will not get 19. These prime factors, these prime numbers are unique in all respect, and the order, this is the order irrespective or apart from the order. So, this order you can write in the other way around, you will get the same round. You can write 13, 7, 5, you can write in that way also. But it is always better to you write in the ascending order. Study how to find out the SCF and the LCM through prime factorization method. You have studied how to find out the SCF and the LCM through division method. That you have already studied in your previous classes. Today we are going to study how to find out the SCF and the LCM through prime factorization method. So, what is SCF? The highest common factor. What is LCM? The least common multiple. Now, let us take the example of 6 and 20. Now, 6 and 20, 6 and 20. 6, let us do the prime factorization. 3 2s are 6. So 6 can be written as 2 into 3. And now let us take 20. 20 again divided by 10. So it is 5. So it is 5. So 20 can be written as 2 into 5. Now SCF, that is the highest common factor. In this case, please remember one thing. Whenever we take the highest common factor, we take the smallest power of each common prime factor. So each common prime factor, in both the cases, which is common, 2 is only common, we take the highest, the smallest power of each common prime factor. So the SCF is 2. Understood? Now LCM. LCM will be the greatest power involved in the numbers. So which are the greatest number? Here 2 to the power 2 into 3 into 5. So this is 4 into 15, that is 60. So whenever we take the SCF, we take the smallest power of each common prime factor. The common out here is 2. Whenever we take the LCM, we take the greatest power involved in the numbers. So please remember these two things. Now let us find out the SCF of 96 and 404 by prime factorization method. Now this is a solved example in your textbook. Let us do it. We have to find out 96 and 404. Now 96, it is an even number. Let us start with the 2. It will be 48 2s are 96. Again 2, we get 24. Again 2, we get 12. Again 2, we get 6. Again 2, we get 3. So 96 can be written as 2 into 2 into 2 into 2 into 3. Similarly, 404 can be written as, now let us take 404. It is 202, again 2, 101. 101 is a prime number. So it is 2 into 101. Now we have factorized both these composite number, that is 96 and 404. Now in terms we have written from the smallest number to the biggest number. Now we have to find out the SCF. SCF, we have to take the smallest power. So smallest power common. So this is common in both the cases. That is 2 into 2. So 2 to the power 2. Then is there anything else is common? Nothing else is common. So we got the answer SCF is 4. Now let us take the LCM. In the case of LCM, we take the highest power. So here it is 2, 2, 3, 4, 5. So 2 to the power 5. There is only 1 3 and 101. So that is how we calculate the SCF and the LCM. Now you can see the answer. So this is 9696. Now let us take another example. Now we have done 2 composite numbers. Let us do it with 3 composite numbers. The procedure will be the same whether you are doing it with the 2 composite numbers or 3 composite number. The procedure will always remain the same. Now let us take 6, 72 and 120. Now 6 can be written as 2 into 3. What about 72? 72, let us do the factorization. It is an even number, so we get 36, again 2, we get 18, again 2, we get 9, so 3 3s are 9. So 72 can be written as 2 into 2 into 2 into 3 into 3. That is 2 to the power 3 into 3 to the power 2. Now 120. 120 again, let us do the factorization. 120, it is an even number. Let us start with the 2. Again 2, we get 30. Again 2, we get 15. Now let us do it with the 3, 5. So 5, 1. So 120 can be written as 2 into 2 into 2 into 3 into 5. That is 2 to the power 3 into 3 into 5. So we have factorized these three composite numbers in terms of prime numbers. Now let us take the SCF. SCF will be the smallest power. Now let us take the first one, 2. In this first one, which 2 is common in all three, but here there is only one 2. Here there are 3 2's, here again 3 2's are there, but we have to take only 1 2. So the SCF will be 2. Now what about the LCM? LCM will be the highest power. So highest power as far as 2 is concerned, 2 to the power 3. Now 3 is concerned, 3 to the power 2 and 5. So this is how that is 2 to the power 3 is 8, 3 to the power 2 is 9 into 5. So this will be 360. So the LCM is 360. This is how we calculate the SCF and the LCM.